I have to find V1 and V2 in terms of Vs and C1, C2. So if I assign the current I in this series circuit, you can say the drop across or the current through capacitor C1, which is I dV1 dt. Similarly, the current through the same current actually through the capacitor C2, and then if I combine these two capacitors which are in parallel and which are in series, so the equivalent capacitor will be C1 C2 C1 plus C2. So the current I C1 C2, the equivalent capacitor, and the voltage will be of course the full voltage Vs. So the full voltage Vs is coming across the equivalent capacitor, which is the series combination. So dVs dt. So they are all same I because it's a series circuit. So now if I equate this one to this one and see C1 dV1 dt, C1 C2 C1 plus C2 dVs dt. So if I integrate Vs C1 C2 C1 plus C2 and then C1 V1, so V1 is C2 C1 plus C2 Vs. Similarly for V2 it will be C1 C1 plus C2 Vs. As V2, the second one I can find by just equating this one to this one. So yeah, so these are the expressions for the series capacitive arrangements.